Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. So this time, we are going to learn object-oriented paradigm, aggregation. Well, in the previous lecture, we have learned inheritance. We understand that sometimes within a software system, classes may have some relationships among each other. And surely inheritance is one of the important relationships that can exist between classes. So that the inheritance is a relationship between subclasses and superclasses. Or we can say that between base class and the derived class. Okay, the next important relationship between classes is aggregation. Let's take some example directly. A personal computer. Your students major in software engineering, and surely you will do everything, do your homework, your experiment, your assignment with your own personal computer. So let's think about how your personal computer is composed of. A PC composed of CPU and what's more, monitor, and a keyboard or a mouse, and so on. Okay, so personal computer should be called the whole class, and the CPU, monitor, or keyboard, and so on should be called part class. So that means the whole class is composed of the part classes. Next, let's pay attention to the multiplicity. That means numerical relationship between the whole class and the part classes. Let's say one personal computer composed of one CPU and one monitor, one keyboard, one mouse, and so on. Okay, actually this is a quite simple example. And actually aggregation is well applicable. We can see around us many things can be considered as a whole class, and it is composed with some part classes. So let's look at ourselves, a human being. So how are we composed of? Okay. We are composed of one head and one body, two arms and two legs, right? Okay, so you can see this is another example for aggregation, right? And also you can give examples of a table, a building, a university, and so on. Next example. Window. This window is not the window of our classroom. The window means the window in our Windows operating system. And surely now the PPT that we are looking at is a window. So how is it composed? Surely a window is an object, and it can be abstracted as a class. Well, okay, so let's look at this. It's a window, right? And we can see that there are more than one windows on the windows. Let's have a look at these windows. How is it composed? We can see that it has a title, right? So we can call it a title bar. And this part is what? Menu. And this part are toolbar. And this part is the text area. That means that you can edit in this area, and so on, right? And this scroll bar. This is the example of window. So how is it composed? It is composed of one title, one text area, one menu, one toolbar, and two scroll bar. So surely this is another example for aggregation. But to be more exact, it should be called composition. Maybe you will notice that the notation for aggregation are different between these two diagrams. And the notation for aggregation in this diagram for window is a solid diamond pointed to the whole class. But in this diagram, the diamond is hollow, pointed to the whole class. Maybe you will think that I have made some mistake for these two diagrams. Okay. Well, the answer is no. Both these diagrams are correct. So Can you tell the difference? One is hollow and another one is solid. Well, maybe we can think in this way. Maybe your personal computer have been used for years, and it gets slower, and you want to get a new one. So maybe you will fix your personal computer, right? And then you get mouse, a separate mouse, separate keyboard, a separate monitor, and a CPU, and so on. Is your computer still existing? No. You have destroyed your personal computer. Okay? It's not there anymore. It's not an object anymore, right? But how about parts? How about the part classes? They're still there. So you see, monitor is still a monitor. This monitor can be used to some other computer, right? And this keyboard, okay? So maybe you can give this keyboard to a friend if he needs it. Okay, so that means even though the object of the whole class doesn't exist, the object of the part classes are still there. So that means the objects of the part classes won't disappear with the object of the whole class. That means the life of the part classes don't rely on the life of the whole class. Let's look at this example again, window. So let's assume if I close this window, what will happen? If I close this window, how about the part classes? Is the title still there? Or is the menu still there? How about the text area, the toolbar, and so on? So we can see that the objects of the part classes disappear with the objects of the whole class, right? Okay, so in other words, the life of the part classes rely on the life of the whole class. We must admit that the kind of relationship for Windows and the PC is really different. This type, we call it aggregation. The part class can be independent. Well, in this example, the part classes are independent, and we call it composition with this solid diamond. So actually from these two examples, we get a good understanding of aggregation. And never forget, there are a kind of special aggregation, composition. So maybe after class, your student can achieve more examples for aggregation and composition. Maybe you can think after class how to implement aggregation in Java code or in C++ code. Is there any keywords for it in Java or in C++? If there's not any keywords for aggregation or composition in object-oriented languages, how can we achieve such kind of relationship in object-oriented paradigm, in object-oriented languages? So much for this part.